Hi everybody, welcome back. Well, we are starting our last chapter of the course, so yes, the end is near. So this is going to be about polar coordinates. This is going to be very, very relevant if you take calculus, particularly if you take calculus 2 or some higher calculus courses, because it's going to turn out there are some things that can be modeled better with polar coordinates than the usual XY coordinates. And it'll help. We'll see in the next section when we have the certain graphs that are very difficult to graph with X and Y variables, but very easy to graph with polar coordinates. So let me just show you, remind you, or tell you that rectangular XY coordinates, that's what we call rectangular coordinates of a point P. And then the polar coordinates of P are defined as follows. So if you take any point on the plane, that's going to have a unique distance from the origin, and it's going to, the ray connecting the point to the origin is going to make an angle with a positive x-axis. So if we call that theta, and we call the distance from the origin r, that is enough to determine the location of the point on the plane, because every point is going to lie on some circle that's centered at the origin. And that point, well, within that circle, that's going to correspond to a certain angle. Okay, so that's the polar coordinates of a point. So let's say if we want to if the xy coordinate is, let's say, 0, 1, that is right on the x-axis. Obviously, the distance from the origin is 1, and the angle with the x-axis, positive x-axis, is 0. So this, in fact, this is just the same. R equals 1 and theta equals 0. Okay, now we'll see that there's some other possibilities for R and theta later, but we'll keep with the obvious one. What about 0, 1? Well, 0, 1 is up here. And once again, we're 1 unit from the origin. But now the angle is 90 degrees, but we don't use 90 degrees. We're back to using just radians. So that would be pi over 2 radians. Okay, negative 1, 0. The distance from here to here is 1. And the angle from here to here is 180 degrees, but in radians, that's pi radians. From 0, negative 1, that is, once again, we're 1 unit from the origin. And this angle right here could be, we could take 3 pi over 2. We could also say that this angle is negative pi over 2. It's actually going to be the same thing, because we'll see in a moment that the polar coordinates are not unique. About 1, 1. 1, 1 is over here. And this distance right here, well, we have to use the Pythagorean theorem or some trigonometry. We know that from the Pythagorean theorem that this distance will have to be the square root of 2. So that's what r is in this case. And this of course splits the first quadrant in half, so this angle has to be 45 degrees, which in pi radians is pi over 4. So that would be the polar coordinates of 1, 1. Negative 9, 0. That's way over here. Okay, 9 units from the origin. And the angle from here to here is 180, which is the same as pi. Okay. Square root 3 over 2, 1/2. You might recognize that these are the coordinates for the cosine and sine of 30 degrees, or pi over 6. Okay, this is on the unit circle, and so this point would be, so r would be 1 because it's on the unit circle, and the angle that it corresponds to is pi divided by 6. Now, in the case where r and theta are given, let's say 6 pi over 2. So pi over 2 means it's going to correspond to this part of the x-axis and of the y-axis, and we're 6 units from the origin. So 1, 2, 3, 4, 5, 6. Okay, so the coordinate of this, the x and y coordinates of this would be 0, comma 6. Okay, let's put this one example off till a little later. Once again, this one, when r equals 1, that means we're on the unit circle, and we know that the angle negative pi over 4 gives us a point here, and we know that that point is positive root 2 over 2, negative root 2 over 2. So that would be this point. Okay. And when r equals 0, it doesn't matter what the angle is. When r equals 0, we're just right here at the origin, and that's the only thing it can be. Okay. All right. Now, as I said before, the polar coordinates are not unique. As you see in your notes, for example, 3, 0. So if you take the point 3, 0 in polar coordinates, well, in this case 3, 0 is the same as it is in rectangular coordinates. But we can see that we can add one revolution to this. Add 1 revolution is 2 pi, so we could replace 0 with 2 pi, we get the same point. Okay. We could also take we allow r to be negative, and this is kind of weird because we said r was distance, and usually we say distance can't be negative. But because for various reasons we allow r to be negative, as long as we understand what our angle, what theta is. And in this case, theta is pi, so that would normally correspond to this part. But r is negative, so we're going in the other direction. So we go r, even though the theta is pi, we get 3 units in the opposite direction when we get this. Okay. Similarly, we could add any multiple of 2 pi to this angle, and it will also work. We could add any multiple of 2 pi to this and keep the 3 here. And like we said, we could have 2 pi, or we could have 4 pi, or 6 pi, or negative 2 pi, or negative 4 pi. Okay, any multiple of 2 pi works, as long as the 3 is here. Okay, so in general, r and theta, r can be replaced with negative r if we want, as long as we add pi to that angle. Okay, and theta can be replaced with any theta plus any multiple of 2 pi. So, for example, like this is the same thing as negative 2 7 pi over 6. Okay, because if we take that, we would have pi over 6 is here. That's this angle. But then 7 pi over 6 is that we're just extending this same line. Okay, so if we go 7 pi over 6, we go 2 units back, we get this point right here. Now, what is this point? How do we get the conversion formulas? It's not too hard, because we're just using the Pythagorean theorem. So if we have a point up here, if this is r and this is theta, we can easily enough get a right triangle here, right? Where this distance is x and this distance is y. So by the Pythagorean theorem, we get x squared plus y squared is equal to r squared. We also get from basic trigonometry, because the r is the hypotenuse, x is the adjacent, and y is the opposite. So we get that, cosine of theta is equal to x over r, and sine of theta is equal to y over r. We can just multiply both sides by r, and we get these equations here. So computing x and y, once you're given r and theta, is very straightforward. when you're given r and theta, it's a little bit, when you're given x and y, it's a little tougher. R squared is always equal to x squared plus y squared, and of course usually this would mean that r is going to be the square root of x squared plus y squared. I say usually because sometimes we will want r to be negative. So sometimes we'll want, this could be a negative, the negative square root, depending on what our purposes are. Tangent of theta is always going to be, well, so the tangent is going to be y divided by x, the opposite over the adjacent. But so theta could be just the inverse tangent of y over x, but not always. Because the inverse tangent of anything has to be between negative pi over 2 and pi over 2. So that means that x has to, that we have to be in the first quadrant or the fourth quadrant, which means x has to be positive. So if x is positive, if it's not, then we have to add pi to it. Okay, then but that would put us in the other quadrant. So this would be tangent of the inverse tangent of y over x plus pi if x is negative. Okay. All right. Now, obviously, you could replace pi with any multiple of pi. That doesn't change the tangent. All right. So let's look at maybe if we go back to our original thing here, where we had r was 3 and theta was pi over 3. So x would be 3 times the cosine of pi over 3, which is cosine of 60 degrees is 1/2. So I believe this is 3/2. So that's our x. And y would be 3 times the sine of pi over 3, which is 3 times square root 3 over 2. Okay, so that would be how we do that. Okay, going on to our examples here. Okay, we basically did the same thing, except number 1 is basically the same thing as what we did. We just have r is negative 2, so x would be negative 2 cosine of pi over 3, which is negative 2 times 1/2, or negative 1. Y would be negative 2 sine of pi over 3, which would be negative 2 square root 3 over 2, which would be negative square root 3. So the angle would be, so xy would be negative 1, negative square root 3. Here, I'll let you think about number 2 and 3, and I'll let you work on those for a moment. Okay, here we are again. So hopefully you got this first part. So here we have negative, so plugging everything in, we get negative square root 3 over 2, negative 3/2. And sure enough, you see, as soon as you see that we have a positive value of r, and 7 pi over 6 is in the third quadrant, so this point should better be in the third quadrant. Now, number 3 is a little bit different because we need our calculator. Okay, r is 2, theta is 5, so x is going to be 2 times the cosine of 5, and y is 2 times the sine of 5. Sorry about that. Okay, but you really need to use your calculator. So taking your calculator out and make sure that your calculator is in radians. Okay, that's what this is. So this 2 times the cosine of 5. On my calculator, it said that this was 0.567, and then y was 2 sine of 5 is negative 1.918. So this would be Okay. And you know your homework will tell you how many decimal places you want to round this off to. All right. Then let's look at example 4. Now we're going in the other direction. We are going to find out what r is, and we need to find r and theta. Finding r is no problem. You just plug this into the formula, so this r is going to be square root 3 squared plus negative 1 squared. So this will be 3 plus 1, which is 4. And of course we have to take the square root. So r is 2. Okay. And okay, and then what's the let's think and just check what is our what quadrant are we? It's always a good idea to check and just plot the point to see where you are. And we are in the 4th quadrant, right? Okay. So the tangent of theta is going to be negative 1 over square root 3. And so theta is going to be the inverse tangent of negative 1 over square root 3, which is just negative pi over 6. Okay. And okay, so that was, y was negative, so x is positive. We just had to, we're in the right quadrant, so we'll just say that, so r theta is 2 negative pi over 6. And of course, you could have also said, an acceptable answer would be negative 2 positive pi, not 5 pi, 5 pi over 6 would also been an acceptable answer. Just add pi to this, because 5 pi over 6 would correspond to this. You could have add 2 pi to this, and you get 11 pi over 6, and so on. But I think this is our answer. All right. xy equals 5, 5, so r is going to be the square root of 5 squared plus 5 squared. So this is going to be the square root of 50. And then the tangent of theta is 1. X is positive, so theta is going to be the inverse tangent of 1, which is pi over 4. So r theta will be square root of 50 pi over 4. Okay. Number 6 is similar. R will be the square root of 7 square root 2 squared plus negative 7 square root 2 squared. And this is going to be the square root of 98 plus 98. When you square 7, you get 49. When you square 2, you get 2. 49 times 2 is 98. And 98 plus 98 is 196, which is, luckily for us, it's a nice nice whole number, like 14. And then the tangent of theta is going to be y divided by x, which is negative 1. X is positive, so theta is going to be the inverse tangent of negative 1, which is negative pi over 4. So our answer would be 14 negative pi over 4. Okay, over again, you could replace negative pi over 4 with 9 pi over 4, or I'm sorry, 7 pi over 4. Add 2 pi to that. Depends on what, and if they ask for a certain range, then you want to put it in that range by adding the correct multiple of 2 pi to it. Okay, number 7, r will be the square root of negative 2 squared plus negative 3 squared. So this will be the square root of 4 plus 9, that's 13. And the tangent of theta is going to be negative 3 divided by negative 2, or 3 halves. Okay, but notice that x is negative in this case. And if you plot this point, it will be in the third quadrant. Okay, so theta in this case is going to be the inverse tangent of 3/2, but plus pi. Okay, and this will turns out to be 4.124. So the polar coordinates would be square root 13, 4.124. Okay. And you, by the way, you can take your calculator. If you're, you can always take the calculator and find out what these square roots are. Obviously, if your homework is asking you to round it, you take out your calculator. Okay. So why don't you just take a moment and pause the video and do problems 8 and 9. Okay, and then hopefully you came up with this. For this case, we are still, negative 1, 2 is still in the, x is still negative, so we have to add pi to the inverse tangent of negative 2 over negative 1. So that's 2.034. And in this case, this point is in the fourth quadrant, so x is positive in this case. So we just take the inverse tangent and we don't add anything to it. So we get square root of 34 plus, and then negative 1.030. Okay. So too bad. Once you get a little practice, on the next video we're going to see what effect this has on converting equations from one coordinate to the other. Okay. See you then.